the differential of this function y given by y is equal to 1 over x with respect to x, right? So we can do that. Now we know that d, okay, differentiating the function y with respect to dx, okay, what does it mean? So we are differentiating the function. Now remember, this function we have, which is written as 1 over x, can also be written, right, as x, right, to the power negative 1. Good. Now what does that mean? Okay, please, if you haven't watched the first video, you can pause this video, scroll up, watch the first video where you can learn the introduction to differentiation, and then come back and watch this one. All right, so it can be written as this. So this simply means we are differentiating the function, this one here. Okay, this makes it simple, but anyway you can use, it's okay. All right, now what does it mean to differentiate this function? It means we'll first multiply the power in front of x. So it means our power is going to be multiplied there in front. So we are going to have negative 1 multiplied by x, right? Now the power, remember from the previous video, what do you do with the power? You subtract 1. Okay, now what are we going to have here? What we are going to have is, so this is the solution, remember. So what we are going to have is negative x, right? That's negative x to the power negative 2. Now this can be written as negative 1, right? That's negative 1 over x to the power 2, right? Good. So this is the differentiation of this function we have, that is the differential of 1 over x. Okay, now if you look at this, this is what we have right here. Now we want to integrate it. Remember, we are comparing what happens when you differentiate a function and then you integrate it. So let's do that. Now just allow me to change the color of the pen that I'm using, right? Okay, so let's change. So what does this mean? Now let's integrate this time, right? Again, what does integration mean? So this one can also mean as we want to integrate. Again, this function can be written in this form, right? We want to integrate negative x, right? That's negative x to the power negative 2. So we are integrating this function with respect to dx. Good. Now let's proceed. How do we integrate? Integration, we know that integrating something, we use the formula where x, this power you have, you need to add 1, right? Then you divide by the new power, which is n plus 1. Good. So if we apply this to this function now, right? So if we apply this now, so let me just put it here. So if we apply this now to the function that we want to integrate, right? So this will mean this function, right? It's going to be, remember, integral. We are going to have negative x to the power negative 2. Now we are adding 1 to that power. So we are adding plus 1. Then we divide by the new power, which is negative 2, right? Plus 1. Good. Now, plus 1, again, we have plus c, which is the constant, right? So let's proceed. What are we getting? So what we are getting as our numerator, we are going to have negative x, right? So we have negative x. Now the power, we have negative 2 plus 1, that is going to be negative 1. Divide. What are we going to have as the new power? Negative 2 plus 1, that's negative 1, right? Now we can divide negative and negative. So this is going to give us x, right? X to the power negative 1, right? Now this can be written as 1 over x, right? Now remember, we have plus the constant c, right? And here we have plus the constant c. So we can just say the integral of negative 1, right, divided by x squared with respect, so remember we integrated this with respect to x, is simply what we have gotten here, right? So just this part. So excluding c, which is the constant, you can tell that when you differentiate a function, right, this function we have, when you differentiate it, what you get, the differential of that function, when you integrate it, it gives you back that function you had, and you can see right here. Okay, right? So that is the relationship. Let's also solve the second one and see what you are going to get. So in the second one, we want to differentiate this function, which is d, right? The function, want to differentiate this function with respect to dx. Now what function is it? The function is let me just do this so that we can be quick. So the function we want to differentiate is right here, this one here. So this is the function we want its differential. So what are we getting if we differentiate? Remember, each term, what do we need to do when we differentiate? So we subtract the power, the first one. So again, make sure you have watched the first video, the introduction video to differentiation versus integration, for you to understand this these questions, the solutions. So if we differentiate x, we are getting 1, right? Minus, if we differentiate this part right here, we are getting 4x, right? Remember, we are multiplying the power with the coefficient of what we have. So the power that is going to remain is just 1. So we can just write it that way. And then here, we multiply the power in front. Then we have x. The power, we subtract 1, and we have 2. So this is the differential of this function. Now I want to integrate this, compare this to what we have here. So the differential that we have gotten of the function given by y is equal to x minus 2x squared plus x cubed. This is what we have. So this time we want to integrate it and see what we are going to get. And something noteworthy is that we have the range in which we want to integrate this one. Okay, that's something new, right? But don't worry, you are going to learn how to do it. So let's integrate. So if we integrate 1, we are getting x, right? Now if we integrate 4x, what does it mean? So we're going to have 4, right, x. Sorry about that. So we have negative 4x. Now the power, the way it is, x is to the power 1. Now remember, when integrating, we add 1 to the power, so we are going to have to the power 2, right? Then we divide by the new power, which is 2. There we go. Again, plus, we have 3x, the power is 2, we add 1, we are going to have power 3. Then we divide by the new power, which is 3, plus, what are we, plus c, right? Okay, that's c we have, but we still have the limits. We are integrating from -1 to +1, right? In this case, since we have the limits, we don't even need the constant. Okay, so you can just leave it out. So now the issue is now to substitute this limit. Okay, when we substitute, then we subtract the lower limit. So start by substituting the upper limit, then subtract the lower limit from the upper limit after you have substituted in your expression that you have found after integration. So that means we are going to have x, which is 1 minus 4. We have 1 squared, right? This is what we have, minus 1. Divide this by 2, plus, we have 3, right? If you want, you can cancel there. I just don't want to cancel because I want to show you how everything is moving. So we have 3 there, right? We are done. So this part minus the second part, which will contain the substituted lower limit, which is -1 minus 4, right? Open bracket, -1. Now this is squared, right? Now we are dividing this by sorry, that's not 3 but 2. Okay, so we are dividing this by 2, then plus, again we have 3, -1 cubed, divide this by 3. Good. Now look at this that we have 2 into 4, it can go there, right? So we're going to have 1 minus 1, again 3 can go into 3, so we're going to have again plus 1, right? So this part we are done, minus. Now look at this. Now what we have here, we have 2 can go into 4. How many times? 2 times. And we have -1 squared, which is just 1. So we're going to have here we have -1, right? Minus 1, right? Okay. Then plus 3 can go into 3, right? And then this will give you plus minus 1, right? So this is what we are getting. Now we know that this and this this will give us just a 0, right? Hope you can see that. We have +1 and -1, so we're going to remain with 1. Then minus, we know that this is going to be that's just open bracket, -1 minus 1 minus 1, that's -3, right? Okay, so make sure we haven't made any mistake. So this will give us 1 plus 3, right? So this will just be 4. So integrating this function, we could see that after integrating this function that we were given, we got back what we differentiated, right, from here. Again, we want to integrate this with the limits. the upper and the lower, this is the value that we get. So this is how you integrate the equation that will be given, a quadratic equation with the lower and the upper limits. All right, thank you so much. Now let's do the last one here.